The lesson topic for this video is finding 6 trig ratios in special right triangles. Alright, so this lesson is actually going to be very similar to the previous lesson, so I'll try to just do 2 quick examples. The only thing we're adding here that is different from the previous lesson is the last step here in the lighter purple. So again, we're going to draw our angle in standard position. We're going to find the measure of our reference angle, theta prime. We're going to draw and label the sides of the special right triangle that is created, and always use our negatives when they need to be used. And then we're going to just write the 6 trig ratios for theta prime. Alright, so we're going to start by drawing our negative 240 degree angle in standard position. We've got our point here and our original or initial side on the positive x-axis. We are going negative 240. Remember, that means we're going to go from here clockwise. That's 90, 180, 270. So we know it's less than 270. 240 is in this region here. So we're going to draw that ray right here, and this is theta. Okay, I'm actually going to erase the symbol I just put on there just to make sure we can put our theta prime in there really clearly. Okay, so we're going to draw our reference angle, theta prime, like we've been practicing, and we are going to find the measure of theta prime. So if you think about, we know that this is 180 degrees here. If we were rotating counterclockwise, we would know that's negative 180. And we went beyond the 180. We're moving this red initial angle all the way to here. We went past the 180 degree angle. How far to get to 240? And that answer is 60 degrees. So we know theta prime is 60 degrees. Okay, so we're going to draw our special right triangle that's created here, and if we bring this straight down like always for our right triangle, we know that theta prime in here is 60 degrees, and that's 90. So if we have 60 degrees and 90, we know this up here is 30 degrees, and therefore we have a 30, 60, 90 right triangle. Alright, so I'm not sure if I can squish a 60 in there. I did. Alright, let's label our sides with their lengths. And since this is a 30, 60, 90 triangle, we know that across from the 30 degree angle is our side that is 1, but we also have to think about direction or negative, so we know we're going left, which is negative 1. Across from our right angle in a 30, 60, 90 is always 2, and the side that's across from the 60 degree angle is always the square root of 3, positive or negative in this situation. Which one? We're moving up, so that's positive, so we'll keep square root of 3 positive. So we've labeled our triangle, and that is where we left off yesterday, and we did a little practice, or the previous lesson, and now we are going to write the 6 trig ratios for theta prime. Alright, so if we want to write sine of theta prime, cosine, and tangent, we can start there. Our sine ratio we know is opposite over hypotenuse. Sine of theta prime, which is our 60 degree angle, sine is opposite, square root of 3, over hypotenuse, which is 2. So square root of 3 over 2. Cosine is adjacent over hypotenuse. Adjacent is negative 1, and hypotenuse is 2. And lastly, tangent for theta prime is opposite over adjacent, which is square root of 3 over negative 1. Now, without even looking at the diagram, we can write our other 3 trig ratios. Typically, the easiest for people to remember is cotangent matches up with tangent. It's the reciprocal, so negative 1 over the square root of 3 there. Remember that cosecant sounds kind of like cosine, but it doesn't go with it. It goes with sine. So cosecant of theta prime is the reciprocal of sine. And lastly, we have secant of theta prime, and that is the reciprocal of cosine, so 2 over negative 1. Okay, so one last example here. Instead of a negative angle, we're going to start with a positive 495 degree angle for theta, which means we'd have to, of course, go 360 degrees around plus some more, right? So we have to find out how much further we go for that coterminal angle. We're going to subtract 360. We get 5, 3, 1. We get 135. All right, so 135 degree angle is right about there. And now we are going to go ahead and draw our reference angle, which will be that. All right, so that's theta prime. We're going to find the measure of theta prime. Well, if we know this is a 135 degree angle and we need to rotate this many degrees to get to 180, well, you can just think about how 180 subtract 135 is 45 degrees. So theta prime right here is 45 degrees, and that means if we dropped this segment here, we'd have a 45, 45, 90 triangle for our special right triangles. So we're going to go ahead and label the sides of the special right triangle. Across from the 45 degree angles are 1 and 1, but remember we're moving left here, so that'll be a -1, and we're moving up here, so that will be a +1. And the hypotenuse of a 45, 45, 90 triangle is always the square root of 2. All right, and again, all we have to do at this point is write our trig ratios, sine of theta prime, cosine of theta prime, tangent of theta prime, and then we'll write the reciprocal fractions for cosecant of theta prime, secant of theta prime, and cotangent. Sine is opposite over hypotenuse. Sorry, I was pausing here. I'm like, all right, we're using our 45 degree angle, of course, because that's where theta prime is. So opposite over hypotenuse is 1 over square root of 2. Adjacent over hypotenuse will be -1 over the square root of 2. And tangent will be opposite, which is 1 over adjacent, which is also, sorry, not also, but is -1. So 1 over -1. We take the reciprocals for the other 3 trig ratios, and we are good to go.